Hello, welcome back today. And today I'm going to take you to the standard deviation and variance. Then my second part will be reshape and transpose in matrix. So let's start with the standard deviation and variance. So in this part we have to import the matplotlib and then numpy. So go import matplotlib matplotlib.pyplot pyplot SPLT SPLT then import SNP. That's it. So I'm going to construct an array, two types of array. One is gonna be a high variance array, and the second one is gonna be a low variance array. So let's start with the high variance array. High variance array. Let's say just any array. I'm gonna give high variance array. Then this gonna be np dot array. So this can be 100, 200, 4,000, then 5,000. So what do you mean? What do you mean by a variance? We're going to look at a variance. So variance measures how far data is spread from the mean. That's what we know. Measures how far data is spread from the mean. And we have to test this using a high variance array and a low variance array. So this is gonna be 4,000 and it's gonna be 5,000. So that's it in the low variance array. We'll just copy this and paste it down here. So this is gonna be low variance array. Low variance array. This is gonna be np.array. So we can give this an interval of 2 and 10 there. So let me write. So I want to show you the difference between the variance. As we mentioned that variance is it shows how far data set is spread from the mean, and we are going to look this using a plot. Yeah, a plot. So plt. We import a matplot as plt. So plt dot histogram. It shows us the spread of this data. So this is here. Then I'm gonna display our histogram here. So, so this you see here, this shows that there's a more concentration on this side than this other side. So this it's not evenly distributed. What about the low variance array? I want to see. You can see here the reason why this is not even distribution. We can see what is one is from ranging here 1 to 5,000. That's a very big range, and intervals 1 to 1,000 and 1 to here was supposed to be 200, but that's fine. And then here 4,000, 5,000. We can see there's a very big range between the maximum and the lowest. What about the low variance array? Here you can see that there's a very small difference from the highest to the lowest. And I'm going to show you I'm going to show you how this is evenly distributed when we plot a histogram of the low variance array. So let me just copy this, paste it here, and then show you this with a low variance array. So it's gonna be low variance array, low variance array. There we go. We can see that this is evenly distributed, not like the high variance array. And then, so I hope you can see the difference there. And then I told you the second thing I'm gonna show you is reshaping and transposing matrix. You remember the first time when we were trying to conduct a, let's say, multiplication between one matrix and another matrix, we encountered a problem like with the broadcasting cannot match. So let me show you what I'm speaking of. A1, let's say A1 of matrix and dot array array of, of 1, 2, 3, 1, 2, 3, 1, 2, 3, 6, 7. Just keep it this way. Yeah. And then let me just copy and paste the other part so that it's gonna be easy. And then we have our second matrix that's gonna be A2, and let me just copy it and paste it down here. There we go. And then there was the A3 from the last tutorial. The A3 was just copy and paste it again. Here we go. This was A3. So this being said, you remember last time we tried doing a multiplication of matrix A1 by A3, and we get an error message saying operands could not be broadcasted together with shape 2, 3 and 2, 3, 3, 3. So what do we do when we encounter such a problem? We either have two options, have the reshaping and transpose. And then, so let's just basically look through the rules of broadcasting. Rules of broadcasting here. Broadcasting rules. Broadcasting rules. See. So this being said here, let's go here. You can see here, when operating on two arrays, NumPy compares the shape element-wise. It starts with a trailing rightmost dimension and works its way to the left. Two dimensions are compatible when first one is when they are equal. Let's say a matrix 2 by 3 and 3 by 2, that's equal, or when one of them is 1. And we can see from here, you can see from here that this is, let's try to see the shape of A2 dot shape and A3 shape, A3 dot shape. You can see A2 has a shape of 2, 3, and A3 has a shape of 2, 3, 3, 3. That's why operands could not broadcast, could not perform a multiplication. So what do we do with that being said? We have only one option here. We have to convert one. We have to convert one, or one of them is equal to. So what do? We have to do a reshaping here. So let's reshape our A2 to become reshape. Reshape. Let's give it was 2, 3. So let's give it 2, 3, and 1. Yep. So this is how it comes. And then for us to do the multiplication, let's just rename it here. Let's rename A2 reshape that way. Yeah. So reshape is equals to this. So that's it. So let's try to do the multiplication of A2 A2 reshape multiplied by A3. You can see that this time we are successfully in doing the multiplication. So that shows how we reshaped our matrix to be now 3 dimension. So 2, 3, and 1, which is compatible with the A3. And then another way of doing this is doing a transpose. And what is a transpose? A transpose, let's say for those who have go through some statistics for linear algebra. In linear algebra, transpose of a matrix is an operator which, let's say, it switches row and columns, and it switches rows and columns. So let's say if a matrix was 2 by 3, what it just do, it does a transpose by flipping a matrix to be, let's say a matrix was 2 by 3, so it flips it to be 3 by 2. And let me show you how to do this. Let's say A3. What's the shape of A3? So it A3 dot shape. So let's watch what happens when we do a transpose. Transpose dot dot dot, and then so we see. So let me show the shape of A3 dot A dot shape shape shape. So here the shape of A3 was 2 3 3, and now the shape is 3 3 2. So what a transpose does is takes this 3 here, comes here, 3 3, and 2 is gonna be the last. So that's it. Thank you so much.